Hey, and welcome to episode 6 of the Climate Com podcast. And today I'm joined by Professor David Dilley, and he's created a presentation for us, which I'm really eager to get into. And I'm very interested to hear what David's going to say about the Climate Con. And also, I think it's going to be focused on CO2 specifically, but also we'll have some other things in there. So, welcome to the show, David.
Well, thank you very much for having me on. And we are starting to make some traction around the world. And one of my other podcasts on about a month ago is doing well, and it's catching on, actually. It's actually picking up steam. So hopefully we can do that with yours also.
Awesome, good to hear it. So, do you want to give a bit of an introduction about yourself if anybody hasn't heard
Sure,
of
I
you before?
will.
Yeah.
Okay. Well, I have 50 years of experience, and how that happened, I don't know. I'm only 25 years old, but no, I have 50 years of experience in meteorology, climatology, former meteorologist with the NOAA, National Weather Service here in the United States, United States Air Force. Right now, I'm the senior research scientist and meteorologist, climatologist, global weather oscillations. And one of our principal jobs is doing hurricane forecasts. Here at Global Weather Oscillations, I created what I call, or is called, climate pulse technology. That's for tracking the climate and weather events such as hurricanes from the past up to the present and into the future. And it is based on proven science. It's a subset of the Milankovitch cycles, electromagnetic interactions between the Earth, Moon, Sun. And as I was saying, specialize in climate change, research, and predictions. Teaching climate change. That's what I'm doing right here today. Teaching climate change, natural climate cycles. Author of the ebook, it's peer-reviewed, Earth's Natural Climate Pulse. I have 8+ videos and podcasts online on YouTube and some on our website also. And we do hurricane landfall predictions, where I actually predict hurricane landfalls 6 to 8 months in advance using past cycles, natural cycles, and climate pulse technology. Well, as we get into global warming, a lot of people say, well, what's global warming? What's global cooling? Global warming comes about 230-year cycle. It begins in the Arctic and the Antarctic. During the course of about 20 years, the two polar regions warm up. And as they warm up, there's less air, warm air, or less cold air, I should say. The air is not as cold coming down into North America and Europe during a building global warming cycle. So what happens with less cold air coming down, the mid-latitudes warm up. Not the tropical regions, but the mid-latitudes. And that is global warming. As I said, it takes about 20 years for it to build to its peak. Just built to its peak in 2022. I would say was the peak of it, and now it's going down. Now, the global cooling cycles also begin at the polar regions. The North Pole, the Arctic in 2022 had its coldest spring and summer on record. And that didn't really even make it into the news. It was kind of buried. And also, looking at it, and I'm going to show you a graphic on it in a minute, right now, April into June is acting like last year also. Colder than normal temperatures in the higher Arctic. This is the first time this has happened since prior to 1958. So the polar regions are cooling down. And as it cools down, what happens? You start getting colder air. It does take us time to build into the global cooling cycle again. But as the polar regions get colder, what happens is the cold air eventually makes it down into the mid-region, and there we are in global cooling. These cycles come every 230 years, and we'll talk about it a little bit in the, again down the road here. So just recapping that, the winter of 2020 was the third coldest January and February on record from Alaska through central and northern Canada into Greenland. Antarctica, winter of 2021, coldest on record. And in the high Arctic in 2022, coldest spring and summer on record since at least 1958, if not prior to it. And most ice extent in 8 to 16 years. And this is occurring again this spring into the early part of the summer. So things are changing. And this is the actual graphics. This is out of the Danish Meteorology Institute. And this is last year, 2022. The blue line is the mean temperature for the high Arctic from 1958 to 2002. But what we see is the orange line from April to August, it was colder than normal up in the high Arctic. That was in 2022. And that brought some unusual weathers to some parts of the Northern Hemisphere. Here in the United States, California had one heck of a winter, and also record snowfalls, and even had some record snowfalls in the eastern United States, and parts of Europe had unusual events also. So it's starting to creep in. And as far as current, right now, this is also out of a Danish institute. This is April of this year. You can see the temperatures are again running below normal, below the long-term average up in the high Arctic. So this is 2 years in a row. This had never happened since they've been recording this back to 1958. So the polar region is cooling down. And the ice extent, this is as of right now, the black line is this year, 2023. Red line is just the past month or so. And you can see the red line here. The little gray line is the long-term median average during 1981 to 2010. So you can see the ice has actually increased over the period years of 2018, 19, 20, 21, and 22. We have a greater ice extent now in the Arctic. So everyone's saying, oh, Arctic's melting. Not really. It's actually starting to restore. Al Gore and the group back in the late 1990s and a lot of big groups, IPCC, in the middle part of it, as late as 2010, said the Arctic would be ice-free in 2023. I'm afraid not. It's going in the other direction. So the question, big question mark, is current global warming caused by the rise in CO2 since 1850, as what we hear from the IPCC and all the media and governments? Or is it natural cycles? And we're going to take a walk through this, and you're going to be astonished. So carbon dioxide and carbon and climate cycles. Well, this is from ice core samples in the Antarctic. Present day is on the right, and we go back on the left-hand side is back 450,000 years ago. This is from ice core samples. The red line is temperature. And you can see during that time, just a course of 8 to 10,000 years, we come out of an ice age into what we call an interglacial warm period. Interglacial warm period. So the temperature peaks out, and the blue line is carbon dioxide. You can see the carbon dioxide comes up after the temperature comes up. It follows it by 6 to 7,000 years. So we had a warm period back about 440,000 years ago, but it cooled down into an ice age again, and then warmed up over a course. It really warms up fast when we come out of the glacial period. And this particular slide, you can see how the temperature rises rapidly. And the blue line, carbon dioxide, you can see how it lags way behind by about 7,000 years, way behind. And then when it cools down, going towards an ice age, temperature drops like a rock. But look at the carbon dioxide, it's still way up high 7,000 years after the temperature starts dropping. So carbon dioxide does not cause global warming. It's just a byproduct. It increases during the global warming interglacial warm periods. And so that's how we go in all the times here. And then 18,000 years ago, and about 8,000 years ago, we popped out of the, whoops, hold on. Oh, okay, I guess it wants to go to the next slide. It pops up out of the glacial period about 8,000 years ago. And here we are at 424 parts per million. Now that's instrument readings. We have to remember, we've never had instruments recording this prior to 1958. So this is instrument readings compared to ice core readings. And on the next graphic, we'll just look at the carbon dioxide itself going back 800,000 years ago. But you can see the parts per million out of the ice cores, and I'm going to get into the ice core samples and show the problems. You can see 263 parts per million got up to 287 about 400,000 years ago, 297, 282, and 285 about 125,000 years ago. So there's a baseline here. They say carbon dioxide in the atmosphere has never been above 300 parts per million. Well, is that true? This is from ice cores, not instruments. And today we're at 425. So all of a sudden it peaked up and we're saying, no, it's burning fossil fuels. Let's take a look at it. Is the rise in CO2 since 1850 natural? Or is it anthropogenic, us burning fossil fuel, or a combination of the two? First of all, we kind of need to know what makes up the atmosphere and gases. And here's a graphic here. We see how much certain things are. And I have some people, when they go out and do talks and meet people, they ask people, how much carbon dioxide is in the air? And you know what they usually get for a feedback? They say anywhere from 20 to 60% of the air is carbon dioxide. Well, let's take a look at what it is. This first one is 78% of the atmosphere is nitrogen. 21% is oxygen. And 0.09% is argon. That makes up 99.99% of the atmosphere, is what we call the dry atmosphere. Then we have the greenhouse gases, which are variable. That's kind of added on to the rest of it. So on the variable, okay, we're gonna, I guess we'd expect a big spike here for carbon dioxide. Well, the biggest greenhouse gas is water vapor. It runs anywhere from, at times, 0% at the North Pole, the Arctic and Antarctic, but generally 1 to 4% of the atmospheric gases. But that's quite a bit, 1 to 4%. So, okay, now let's see what we have for carbon dioxide. This must be a huge spike. Ooh, didn't even show up in the graph. That's because it's a trace. It's less than 0.05%. That's all it is.
So if I could jump in quickly, like where are people getting the figure that there's 60% carbon dioxide in the atmosphere? How are they even getting that?
Well, it's because they're not teaching it in the schools anymore. This is the people I know that are asking. They go to some of the school fairs, high school and so forth. They even ask some of the teachers. Yeah. And they're all in the anywhere from 10 up to 60% range. They do not understand. It's not taught anymore. And that's the whole problem. Instead, they're getting the misinformation in the media that, wow, carbon dioxide is out of whack and really we're in trouble. To get another better perspective of it, this is just the greenhouse gases here. Water vapor on the average is 2% of the atmospheric gases. Natural CO2 is 0.04%. And what I'm going to show you is that the fossil, anthropogenic fossil that everyone's complaining about is only 0.004%. That's 4/1000th of 1%. This is all a con game. It's used for agenda. It's used for grant money for universities. Universities really don't know any better. They want the money, so they have to accept the grant and do research according to the grant. So this is really a big con game.
Yes.
Now, to better understand it, I'm going to show you how the carbon dioxide has been measured out through history using the ice core samples at Lake Vostok in Antarctica. What it is, it's a big frozen lake. So they drill down 15,588 feet. And at the bottom, that's ice about 800,000 years old. So this is where they get their readings from, the old ice in the Arctic. But are the measurements correct? Are they good, or is it just an estimate? Well, when they take a ice core sample, like there's a little sliver of ice from the ice core sample, that sliver of ice would be maybe as many as 4,000 years of ice. It's because it's compacted so much. The Antarctic is actually a desert because it doesn't get much precipitation. So 4,000 years of ice, of precipitation, does not give you very much ice. And they can't tell 1 year from 100 years or 100 years from 1,000 years because it's so compacted down deep. So what they do is they take a mean value over the course of 100 to 4,000 years. That's a huge period to take a mean value and then say, well, that was our atmospheric carbon dioxide at that time. Well, we're going to show you the problem with this. Taking the mean over 1,000 to 4,000 years. What you do is eliminate the CO2 spikes in the atmosphere or in the ice. For example, say somewhere in the world, this is the annual temperatures, monthly temperatures for some spot where in July it's 90 degrees somewhere. That's for normal high temperature. And their normal low temperature is about 66. Well, you take a mean value of all this over a 100-year period, and it brings the 90 degrees down to 78 degrees. That's your mean. You've chopped off the spike by taking the mean value, and this is what's happened in the ice core samples. So what you have to do is you have to add about 17% back onto your reading, and they do not do that. Another problem is what we call new ice versus old ice. When they do their ice core, they drill down into what they call the old ice. The new ice is the first 5,000 years of formation. Air bubbles form in the ice or are trapped in the ice. And the air bubbles contain carbon dioxide and nitrogen, oxygen, and so forth. But during the first 5,000 years, a lot of that escapes back into the atmosphere. It's lost back into the atmosphere. So it's not recorded. This study says that we lose about 2.6, we lose about 30 parts per million total during the course of 44 feet of the new ice. And the thing is, all the scientists that know anything about the ice core samples know this. They know that these readings are at least 30 parts per million lower than what the actual value is. They know that, but they don't tell you.
And you reckon that's because the grants are sort of bribing them almost to not report it accurately?
Well, what it is that's the ice core reading, so they take that verbatim. That's what the ice cores say. But the ice cores are not correct. They're, because of the two corrections, taking a long-term mean and also the CO2 being lost back into the atmosphere during the first 5,000 years. And this is true science. This is, you can get this on What's Up With That. They printed the link Fern to ice transition. That's a peer-reviewed paper, talks all about it, and all the scientists know about it. Now, the summary, let's do my two corrections. The 17% for a mean value and the 30 parts per million lost back into the atmosphere. Well, this is what all the scientists are using right now. Going back 425,000 years ago, this is the peak of the CO2 in the atmosphere during the interglacial periods. But you can see it never went above 300 parts per million, according to the ice cores. Now, you get to the IPCC and NOAA, the National Oceanic and Atmospheric Administration here in the States. What happens is, well, they say we've never been above 300 parts per million. So everything since 1750 or 1850 has to be from fossil fuel burning. That's what they say. But if we do my corrections, we add on that 17% for taking a long-term mean value, that takes us well above 300 parts per million. Then we add on that correction number 2, the 30 parts per million, that is proven science, where the CO2 is lost back to the atmosphere, not recorded. Add that on, and this is what we get. Look at that, 377 parts per million, 378, 375, 375, and that goes up to the year 2018. So actually, that would even be higher now. Now, we add those corrections, and what does that do to the what NOAA and the IPCC is saying? If we add the corrections, that wipes out most of what they're saying. What it really means is the rise in fossil fuels since 1850 is 80% natural. It's not 100% fossil fuel, like what they're telling us. Now, I'm going to show you 2 more cases that prove this, that back all of this up.
I hope you've enjoyed part 1 of the 5th episode of the ClimateCon podcast. Part 2 is available for members, and you can become a member via the website, which has the link in the description, thegreatclimatecon.com. Thank you for your support.